Hello students and good morning. So now today also we are doing the same chapter, that is integration of some special form of functions. So this is the continuation class of the last online class. So same exercise 8, page number 396, 4 marks section from the book Higher Mathematics for Class 12 by S.N. Day. So let us evaluate this integration. That is, let's do this from question number 18. That is, you have to integrate. Integral sign within bracket, there is a fraction cot x divided by sin x whole to the power 4 dx. So how can you evaluate this integration? So let us first write, therefore I is equal to integration of, this is cot x divided by sin x whole to the power 4 dx, right? So now this power 4 is for both numerator as well as denominator. Or I is equal to integration of, now you can write here cot to the power 4x divided by sin to the power 4x, then you can write dx. Okay, next, now this is cot to the power 4x. Actually this sin to the power 4x is in the denominator. You can write it as 1 upon sin to the power 4x. So or I is equal to integration of cot to the power 4x into, what is 1 by sin to the power 4x? 1 upon sin to the power 4x is cosec to the power 4x dx. So I think you have understood it. Okay, next, so you know the relation between cot x and cosec square x, isn't it? That is, the differentiation of cot x is minus cosec square x. Differentiation of cot x is minus cosec square x. Let us break this term, that is cosec to the power 4x, as cosec square x into cosec square x. So or I is equal to integration of, this is cot to the power 4x into, so let us break this term as cosec square x into cosec square x dx. So as you know that the differentiation of cot x is minus cosec square x, so we need only one cosec square x. So there is another cosec square x, you can convert into cot square x. What is the formula for cosec square x in terms of cot x? It is 1 plus cot square x. So therefore I is equal to integration of, this is cot to the power 4x. What is cosec square x now? You know that it is 1 plus cot square x into, then you have to write cosec square x dx. Cosec square x dx. So is that clear? So next, what is to be done? So now you can use the method of substitution, because you know that the differentiation of cot x is minus cosec square x. That is, if you can assume cot x as z, if you differentiate, you can get the value for cosec square x dx, right? So let us do the method of substitution. Let z is equal to, this is cot x. Now let us differentiate, differentiating both the sides, differentiating both the sides with respect to x. Therefore this is dz by dx is equal to, this is your minus cosec square x, right? This is the differentiation of cot x, that is, differentiation of cot x is minus cosec square x. Now let us cross multiply. So dz is equal to minus cosec square x dx. And now let us take this minus sign to the left hand side. So it becomes minus dz is equal to cosec square x dx. That is, the value for cosec square x dx is minus dz, right? So therefore let us put it in I. I is equal to integration of, what is cot to the power 4x? It is z to the power 4. Then 1 plus, what is cot square x? that is your z square. We are putting the value for cot x as z. So it is z to the power 4 into 1 plus z square into what is cosec square x dx? It is minus dz. So is it understood now? So minus sign is taken outside, or I is equal to minus integration of z to the power 4 within bracket 1 plus z square bracket closed. Then you can write down dz. Okay. So next you can separate the term. You can multiply and separate the term here. Therefore, this is I is equal to minus integration of z to the power 4 dz, right? Minus into plus, minus integration of z to the power 4 into z square. It is z to the power 6. It is z to the power 6 dz, or I is equal to minus, this is z to the power 5 divided by 5 minus, what is integration of z to the power 6? Z to the power 7 divided by 7 plus c. Now you can put the value for z. So I is equal to minus, what is z actually? It is cot x. What is z to the power 5? Cot to the power 5x divided by 5 minus, what is z to the power 7? You put z is equal to cot x. It is cot to the power 7x divided by 7. Then we can write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 19. So let us evaluate this integration. The question is integration of sine cube x dx divided by cos to the power 2 by 5x. So I already told you that whenever you have odd power, you have to break that odd power. Here the odd power is sine cube x. Let us break this sine cube x as sine square x into sine x. And you know that the differentiation of which function is sine x? It is cos x. Differentiation of cos x is minus sine x. So minus sine, you can manipulate it. Okay. That is the differentiation of cos x is minus sine x. So you have to convert that sine square x in terms of cos square x. Right. So let us write first. I is equal to integration of, this is your sine square x into sine x. So it is separated. Sine square x into sine x divided by, this is cos to the power 2 by 5x. Then it is dx. Right? So now, what is the formula for sine square x? It is 1 minus cos square x. So let us convert this sine square x in terms of cos. So it is 1 minus cos square x into sine x, this whole divided by cos to the power 2 by 5x. Then we can write dx. Is that clear to all of you? So now you know that the differentiation of cos x is minus sine x. So we can assume this cos x as z. So let z is equal to cos x. Let z is equal to cos x. So let us write here differentiating both the sides with respect to x. So it is dz by dx is equal to, this is your minus sine x, right? So next, what will you do now? So let us do cross multiplication here, or dz is equal to minus sine x dx. That is dz is equal to minus sine x dx. But we have got only sine x dx out here. So let us take this minus sign to the left hand side. So what is the value for sine x dx? So sine x dx is equal to minus dz, right? So therefore, I is equal to integration of, what is 1 minus cos square x now? Within bracket 1 minus, it is z square, right? And what's about sin x dx? It is minus dz whole divided by, in the denominator, what is cos to the power 2 by 5x? It is z to the power, it is z to the power 2 by 5. So I think you have understood it. So, or I is equal to minus sign is taken outside, integration of, let us separate this fraction, 1 upon z to the power 2 by 5 minus z squared divided by z to the power 2 by 5, bracket closed, and then you should write dz. Okay, so or I is equal to, let us separate the term, minus integral sign, z to the power 2 by 5 can be taken to the numerator, so it becomes z to the power minus 2 by 5 dz, minus into minus, plus integration of z to the power 2 minus 2 by 5, then you can write dz. Is that clear? That means we are simplifying each and every term. Or I is equal to, you can evaluate this integration, minus, this is just like x to the power n, z to the power minus 2 by 5 plus 1 divided by minus 2 by 5 plus 1, okay, plus integration of z to the power, let us simplify it first, 5 2s are 10, 10 minus 2 is 8, 8 by 5 dz, okay. So you can easily evaluate this integration. This is just like your integration of x to the power n dx. Or I is equal to minus, this is z to the power, 5 ones are 5 minus 2, 3 by 5 divided by 5 ones are 5 minus 2, this is 3 by 5 plus, what is integration of z to the power 8 by 5? Z to the power 8 by 5 plus 1 divided by 8 by 5 plus 1. Since we have finished integration, you have to write down plus c, that is your constant of integration. So now let us simplify it. Or I is equal to minus sign. So 3 upon 5 is in the denominator. When it goes up in the numerator, it becomes, this is 5 by 3, then z to the power 3 by 5, right? Then plus sign, z to the power, simplify it, 8 by 5 plus 1, 5 ones are 5 plus 8, 13 by 5, this is 13 by 5 divided by 5 ones are 5 plus 8, 13 by 5, 13 by 5 plus c, right? So or I is equal to, this is minus 5 by 3 z to the power 3 by 5 plus, similarly you can simplify it, this is 5 by 13 z to the power 13 by 5 plus c, okay. So now you can put the value for z. Actually what was z? Z is equal to cos x. So or I is equal to minus 5 by 3, this is cos x whole to the power 3 by 5, right? That is z is equal to cos x, plus it is 5 by 13, this is your cos x whole to the power 13 by 5 plus c. So you can keep the answer as it is. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 20. You have to evaluate this integration, that is integral of dx divided by sine to the power 4x into cos to the power 4x. So how can you evaluate this integration? So in this case, 1 by sine to the power 4x is cosec to the power 4x, and 1 by cos to the power 4x is sec to the power 4x. So you cannot use this formula in this case, okay? So let us convert this sine to the power 4x into tan. So sine to the power 4x should be converted into tan. So in order to convert this sine to the power 4x in terms of tan, you have to divide it by cos to the power 4x. So this cos to the power 4x should be cancelled. This cos to the power 4x should also be multiplied by cos to the power 4x. Okay. So let us write here I is equal to integration of dx divided by this is sine to the power 4x divided by cos to the power 4x. We have divided by cos to the power 4x. This cos to the power 4x should be cancelled. So write cos to the power 4x into, again you have to write down this cos to the power 4x. So if you cancel this, you will get the same question. Okay. So or I is equal to integration of this is dx divided by this one is tan to the power 4x into cos to the power, this one is 8x. Right. So let us simplify it further. Or I is equal to integration of what is 1 by cos to the power 8x. It is sec to the power 8x dx divided by tan to the power 4x. You know that, isn't it? So now there is this fraction is converted in terms of tan x and sec x. And you know that the differentiation of tan x is what? Differentiation of tan x is sec square x. Differentiation of tan x is sec square x. So let us break this sec to the power 8x term as sec to the power 6x into sec square x, so that we can assume tan x as z, such that the differentiation of tan x is sec square x. So therefore this is I is equal to integration of this is sec to the power 6x into sec square x dx. That is sec to the power 8x is separated as sec to the power 6x into sec square x dx divided by, it is tan to the power 4x. Is that clear? So now, since you know that the differentiation of tan x is sec square x, let us convert sec to the power 6x in terms of tan x. Or I is equal to integration of this is sec square x whole cube into sec square x dx divided by this is tan to the power 4x, right? So or I is equal to integration of now this is 1 plus tan square x whole cube into sec square x dx divided by this is tan to the power 4x. So now you can do the method of substitution. Let us assume tan x as z. So let z is equal to tan x, right? Because the differentiation of tan x is what? Sec square x. So differentiating both the sides with respect to x. So this is dz by dx is equal to sec square x. Let us do cross multiplication. So dz is equal to this is your sec square x dx. Understood? So let us put these values in I. So therefore what does I become now? So I is equal to integration of within bracket 1 plus. Now what is tan square x? Z square. This is whole cube. What is sec square x dx? That is dz. So this whole divided by, what is tan to the power 4x? It is z to the power 4. Is that understood? So now you have to simplify this expression. So in the numerator, there is an expression which is in the form a plus b whole cube, or I is equal to integration of within bracket a plus b whole cube. You know the formula, isn't it? A cube plus 3a square b plus 3ab square plus b cube. You should know it. What is a whole cube? 1 cube is 1 plus 3a square b. 3a square b is 3z square plus 3ab square. That is z square whole square is z to the power 4. A cube plus 3a square b is this one, 3z square plus 3ab square is 3z to the power 4 plus b cube. What is b cube? Z square whole cube, that is z to the power 6. Bracket closed. whole divided by, this is z to the power 4, then you can write dz there. So I hope you have understood it. Now let us separate this term now. So let us separate this term. Therefore I is equal to integration of within bracket. Let us separate this term, 1 by z to the power 4. It is 1 by z to the power 4 plus 3 by z square, you know that. So you know how is it simplified. 3 by z square plus 3, right? Plus z square. Z to the power 6 divided by z to the power 4 is z square. Bracket closed. Then we can write dz. Is that clear? Now in this case, this z to the power 4 and z square can be taken to the numerator, and you can separate the term. I is equal to integration of z to the power minus 4 dz. So then you can easily integrate them. Plus 3 integration of z to the power minus 2 dz plus 3 integral sign dz plus, what is the last one? Integration of this is z square dz. So I think you have understood it. Okay. So, or what is the integration of z to the power minus 4? You know that x to the power n plus 1 divided by n plus 1, z to the power minus 3 divided by minus 3, plus 3 into this is z to the power minus 1 divided by minus 1, that is x to the power n plus 1 divided by n plus 1, plus 3z plus this is z cube divided by 3. Then what should we write? Plus c. Okay. So, or I is equal to, this is minus 1/3. 1/3 z to the power minus 3 is taken to the denominator to make it z to the power plus 3. Plus and minus. This is 3 by z plus 3z plus 1/3. This is your z cube plus c. So let us put the value for z now. Okay. So what is the value for z in this case? It is tan x. So, or I is equal to minus 1/3. What is z cube? This is tan cube x minus 3 by z is tan x plus 3. What is z? Tan x plus 1/3. What is z cube? That is your tan cube x plus c. Understood? So again you can simplify it further. Or I is equal to, this is minus 1/3. What is 1 by tan cube x? This is cot cube x minus 3 into, what is 1 by tan x? It is cot x plus 3 tan x is kept as it is, plus also the fourth term is kept as it is, that is plus 1/3. It is tan cube x plus c. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll discuss integration of some trigonometric functions. Suppose you may have integration of this form. Now we'll discuss about integration of the form. So number one is integral sine dx divided by a plus b sine 2x. You may have this type of integration where a and b are constant, right? And b is with sine 2x. So whenever you have such type of integration, how can you evaluate this integration? You cannot just write, you cannot take this a plus b sine 2x as z, because this is not an algebraic function. So this is a trigonometric function. So in this case, you should do different method of integration in this case. Okay. So now in this case, you have to put the formula for sine 2x in terms of tan x, right? you have to put the formula for sine 2x in terms of tan x. So in this case, in order to evaluate this integration, let us first simplify 1 upon a plus b sine 2x. So how can we simplify this a plus b sine 2x? We can use the formula of sine 2x in terms of tan x. Okay, so whenever you have such type of integration, you always put sine 2x in terms of tan x. You know this formula from multiple angles. What is sine 2x in terms of tan x? It is 2 tan x divided by 1 plus tan square x. You can easily evaluate this integration if you put sine 2x is equal to 2 tan x divided by 1 plus tan square x. Is that understood now? So this is the method, right? Suppose you may have number 2, integration of dx divided by a plus b cos 2x. You may have such type of integration. A and b are constant. Instead of sine 2x, you may have cos 2x. So in this case, you always put cos 2x in terms of tan x. So you should know it. What is the formula for cos 2x in terms of tan x? It is 1 minus tan square x divided by 1 plus tan square x. This is the formula that you can use for this integration. Okay, so these are formula from multiple angles in trigonometry. Okay, you may have this type of integration like integration of dx divided by a plus b sine x also. You may have, instead of sine 2x, you may have sine x also. So in this case, what will you do? You have to use the formula from submultiple angles but in terms of tan for sine x. You always put sine x in terms of submultiple angles and in terms of tan x by 2. That is 2 tan x by 2 divided by 1 plus tan square x by 2. So I think you have understood it. Okay. You may have number 4, integral sine dx divided by a plus b cos x also. So instead of sine x, you may have cos x, and you know that a and b are constants. So in this case also, you always put cos x is equal to, in terms of submultiple angle, that is 1 minus tan square x by 2 divided by 1 plus tan square x by 2. So is that clear to all of you? So this is the method for integrating all these 4 type of integration. So whenever you have such type of 4 integration, then we can use this formula from, these are from multiple angles and these are from submultiple angles in trigonometry. Is that clear? So sine 2x is equal to 2 tan x upon 1 plus tan square x. Cos 2x is equal to 1 minus tan square x divided by 1 plus tan square x. These two are the formulae from multiple angles in trigonometry. And sine x is equal to, if there is sine x cos x, that is sine x is equal to 2 tan x by 2 upon 1 plus tan square x by 2, and cos x is equal to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. That is these two are the formulae from submultiple angle in trigonometry. So now we will do problems related to these methods. Okay, so let's do that problem now. So now we'll do question number 21, that is you have to integrate dx divided by 1 plus sine 2x. Just now we discussed about the method how to evaluate this type of integration. That is dx, this is in the form dx divided by a plus b sine 2x. Here a is 1, b is also 1, and there is sine 2x. So you know how to simplify this sine 2x. So you should use the formula from multiple angles. That is sine 2x in terms of tan x. Okay. So therefore I is equal to integration of, this is dx divided by 1 plus. So what is the formula for sine 2x in terms of tan x from multiple angles? That is 2 tan x divided by 1 plus tan square x. So you should know this formula. Now you can easily integrate them. Okay, let us simplify it. Only you have to simplify it, right? Or I is equal to integral sine dx divided by, so what's the LCM out here? It is 1 plus tan square x. You know that LCM. 1 plus tan square x into 1 is 1 plus tan square x plus this is your 2 tan x, right? Or I is equal to integration of, let us simplify this expression. So when this denominator goes up in the numerator, this fraction becomes upside down. You know that. That is 1 plus tan square x goes up in the numerator. That is 1 plus tan square x bracket close dx divided by, this is 1 plus tan square x plus 2 tan x. So I think you have understood it. So let us use the formula. You should use the formula in this case. I is equal to integration of, what is the formula for 1 plus tan square x? What is the formula for 1 plus tan square x? You should know it. That is sec square x. That is your sec square x dx divided by. So now which formula can you use in the denominator? A square plus b square plus twice ab, isn't it? That is, what is a whole square? 1 whole square. What is b whole square? That is tan x whole square plus twice ab, 2 into 1 into tan x. That is, this denominator can be written in the form of a square plus b square plus twice ab. That is your, what is the formula? You know it, a plus b whole square. Or I is equal to integration of, numerator remains same, sec square x dx divided by, in the denominator, what is the formula? A plus b whole square. This is 1 plus tan x whole square. So I think you have understood it. So now you can easily use the method of substitution, because you know that differentiation of tan x is sec square x. Also the differentiation of 1 plus tan x is also sec square x, because the differentiation of 1 is 0 plus, and the differentiation of tan x is sec square x. That means we are getting sec square x. So we can assume, let z is equal to 1 plus tan x. So now let us differentiate it. Differentiating both the sides with respect to x. Therefore it is dz by dx is equal to, for 1 it is 0, you don't have to write it, and for tan x it is sec square x dx. Now let's do the cross multiplication now. So dz is equal to, this is sec square x dx. Okay, so therefore I is equal to integration of, what is sec square x dx? It is dz divided by, what is 1 plus tan x? Z. That is your z square. So you can take it to the numerator. So I is equal to integration of, this is z to the power minus 2 dz, right? So, or I is equal to, what is integration of z to the power minus 2? It is z to the power minus 1 divided by minus 1 plus c, right? So let us simplify it. Or I is equal to, this minus sign which is in the denominator is taken outside, is written in the front, minus, what is z to the power minus 1? It is 1 by z. Then you should write plus c. Or I is equal to minus 1 upon, let us put the value for z. What is the value for z in this case? It is 1 plus tan x. It is 1 plus tan x. Then what should you write? Plus c. So this is the final answer. So I think you have understood this method. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 28. So let us evaluate this integration. The question is integration of dx divided by 5 plus 4 cos x. Now this is in the form dx divided by a plus b cos x. Just now we know the method how to integrate this type of integration. That is, whenever you have dx divided by a plus b cos x, so what is the method? What is the method for integrating it? So first of all, you have to simplify it. So instead of cos x, you have to write it in terms of tan. That is, you can use the formula from submultiple angle in trigonometry. Okay, so let us use the formula for cos x. So I is equal to integration of dx divided by 5 plus 4 into, what is the formula for cos x? 1 minus tan square x by 2 divided by 1 plus tan square x by 2. So I think you have understood it. Okay, now you just have to simplify this denominator. Only you have to simplify it. Okay, so or I is equal to integration of dx divided by, what's the LCM here? It is 1 plus tan square x by 2 is the LCM, right? So now you have to multiply this 1 plus tan square x by 2 by 5. So 5 ones are 5 plus 5 tan square x by 2 plus, now let us multiply by 4. 4 ones are 4, plus into minus, minus, this is 4 tan square x by 2. So I think you have understood it. Okay, so or I is equal to integral sign, this 1 plus tan square x by 2 goes up in the numerator. So let us write it in the numerator. 1 plus tan square x by 2 bracket close dx divided by 5 plus 4 is 9 plus, that is 5 tan square x by 2 minus 4 tan square x by 2 is plus tan square x by 2. Understood? So next, what will you do now? So in the next step, what is 1 plus tan square x by 2? It is sec square x by 2. That is the formula, isn't it? So therefore, I is equal to integration of, what is 1 plus tan square x by 2? It is sec square x by 2 dx divided by, in the denominator it is 9 plus tan square x by 2. So now you can use the method of substitution now. Now differentiation of which function is sec square x by 2? Tan x by 2, isn't it? Differentiation of tan x by 2 is actually sec square x by 2 into half. We are getting that sec square x by 2. We can manipulate that constant half, isn't it? So let us assume z is equal to tan x by 2. So let z is equal to, this is tan x by 2. So differentiating both the sides with respect to x, therefore dz by dx is equal to, this is sec square x by 2. Again differentiate x by 2 with respect to x, that is your half. So let us do cross multiplication now, because you should get the value for sec square x by 2 dx. So let us do cross multiplication. So it is 2 dz is equal to, this is your sec square x by 2 dx. So we have got the value for sec square x by 2 dx, which is equal to 2 dz, right? So or I is equal to, this is integration of, what is sec square x by 2 dx? It is 2 dz divided by 9 plus, what is tan square x by 2? It is z square. Is that clear? Let us convert into standard form. So I is equal to 2 is taken outside, integration of dz divided by, let us first write z square plus, what is 9? How can I write 9? That is your 3 whole square. So now you know that this is the first standard integral in method of substitution. So you should know this formula. So what is the formula for integration of dx divided by x square plus a square? What is the formula? You should know it. This is the standard integration in method of substitution. That is the first standard integral. What is the formula? It is 1 upon a tan inverse x upon a plus c. Okay, so let us use the formula now. I is equal to 2 is constant, you have to write it, into what is a here? A is 3, and what is x? Z. Let us use the formula. What is 1 by a? 1 by 3. Then tan inverse x by a, that is z by 3 plus c. So now let us put the value for z. So or I is equal to, this is your 2/3 tan inverse within bracket 1 upon 3 into what is the value for z. What was z actually? It is tan x by 2. Z is tan x by 2 plus c. And you cannot simplify it further. This 1/3 constant cannot be taken outside. That means you cannot simplify this tan inverse within bracket 1/3 tan x by 2 plus c. Okay, so this is the final answer. This first term cannot be simplified. That is, you cannot take that constant 1 upon 3 outside tan inverse. Okay, so this is the final answer. And this question is also very, very important. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 29. Let us evaluate this integration. That is integral of dx divided by 5 plus 4 sin x. So this question is similar to the previous problem, that is question number 28. But instead of cos x, there is sin x. So here also, I already told you about the method how to evaluate this integration. So first of all, you have to simplify the expression. You have to write the formula for sin 2x or sin x in terms of tan x by 2 from some multiple angle in trigonometry. Okay, so let us use the formula for sin x. So therefore I is equal to integration of, this is dx divided by 5 plus 4 within bracket. What is sin x? 2 tan x by 2 divided by 1 plus tan square x by 2. So this is the formula for sin x in terms of tan x by 2 from the chapter some multiple angle in trigonometry. Okay, so let us simplify it further. Now we have to simplify it. Just simplify it further. Dx divided by, what's the LCM? Here the LCM is 1 plus tan square x by 2, right? So this 1 plus tan square x by 2 is multiplied by 5. 5 plus 5 tan square x by 2 plus, this is 4 2s are 8, and this is tan x by 2, right? So or I is equal to integration of this 1 plus tan square x by 2 goes up in the numerator. So it is, write it within bracket 1 plus tan square x by 2 bracket close dx divided by 5 tan square x by 2, 5 tan square x by 2 plus 8 tan x by 2 plus 5. Understood? So next, or I is equal to integration of, what is 1 plus tan square x by 2? It is sec square x by 2 dx divided by 5 tan square x by 2 plus 8 tan x by 2 plus 5. So I think you have understood it. So we have simplified it. Now we can do the method of substitution, because you know that the differentiation of tan x by 2 is sec square x by 2 into half. That means we are getting the numerator, isn't it? So let us do the method of substitution here, and we can assume tan x by 2 as z. So let z is equal to tan x by 2. So differentiating both the sides with respect to x. So therefore this is dz by dx is equal to sec square x by 2 into half, right? So let us do cross multiplication, or 2dz is equal to, this is sec square x by 2 dx. So I hope you have understood it. So let us put it in I. So therefore I becomes now, I is equal to integral sign, what is sec square x by 2 dx? This is your 2dz divided by, this is 5z square, this is your 5z square plus 8z plus 5. So I think you have understood it. So now 2 is constant, you can take it outside. Now this is the form 5z squared, z and constant is also there. So you should convert into standard form. So we have already done it in the previous chapter, that is in method of substitution, right? So 2 is taken outside. I is equal to 2 integral sign dz divided by. Now in the denominator there is term containing z square and z also. So in order to convert into standard form, first of all you have to convert into perfect square form. And I already told you that whenever you want to convert this expression in terms of a square plus 2ab plus b whole square, you should make the coefficient of z square always positive 1. That is, you take common 5. Make the coefficient of z square 1. 5 is taken common. Z square plus 8 by 5z plus 1. Is that clear now? So this 5 is constant. Since 5 is constant here, you can take it outside. Outside integration, that is I is equal to 2 by 5 integration of dz divided by. Now there remains z square plus 8z upon 5 plus 1. So let us convert this z square plus 8 by 5z in terms of a square plus 2ab plus b square form. What is a whole square? That is your z square plus 2 into a is z into, so 2z is already there. What should be the value for b in this case? So that if you multiply that b by 2z, you should get 8z upon 5. That is 4 upon 5, isn't it? You should get 8z upon 5. 2z is already there. If you multiply it by 4 by 5, we are getting 8z upon 5. Okay. So what is the value for b in this case? It is 4 by 5. So what is b whole square? It is 4 by 5 whole square. Then you should write 1 because there is 1. So we are getting z whole square. That is correct. 4 2s are 8 upon 5z. That is also correct. But what is 4 by 5 whole square? It is 16 upon 25. Is there 16 by 25 here? No. There is 1 there. We have already written 1 out there. But there is no 16 by 25. So there is no term containing 16 divided by 25. You should cancel it. So it is minus 16 upon 25. Is that understood now? So or I is equal to, this is your 2 by 5 integration of, this is dz divided by a square plus 2ab plus b whole square, that is z plus 4 upon 5 whole square. Now let us simplify it. Plus 1 minus 16 by 25. 25 ones are 25 minus 16 plus 9 by 25. Is that clear? So now convert into standard form. Or I is equal to 2 by 5 integration of dz divided by z plus 4 by 5 whole square. This is z plus 4 by 5 whole square plus, write down plus 9 by 25. So 9 by 25 can be written in terms of whole square. That is 3 by 5 whole square. That is your 3 by 5 whole square. So in this case, what is x? X is z plus 4 by 5. And what is a? 3 by 5. So this is the standard form number 1 as we have done in the previous problem. That is, you can use this formula, that is integration of dx divided by x square plus a square is equal to 1 by a. This is tan inverse x by a plus c. So this is the first standard integral from method of substitution. So let us use the formula. I is equal to 2 by 5 into, what is 1 upon a? 1 upon 3 by 5. Then tan inverse x by a. What is x by a? It is z plus 4 by 5 divided by, what is a? 3 by 5, bracket closed, plus c. So I think you have understood it. So let us simplify it. Here 5 gets cancels, or I is equal to, this is 2 by 3 tan inverse. Now within bracket, what's the LCM in the numerator? In the numerator 5 is the LCM. This 5 and this 5 will be cancelled. So you will get 5z plus 4 whole divided by 3 plus c. So let us put the value for z. What is the value for z now? It is tan x by 2. So or I is equal to 2 by 3 tan inverse within second bracket. You can write 1/3. Upon 3 is there 1/3, and then within bracket you can write 5 into, what is z? Z is tan x by 2. You can write 5 tan x by 2 plus 4, first bracket closed, second bracket closed. Then what do we write? Plus c. So this is the final answer. So this question is also very, very important. So you may get such type of integration in your HS examination. So I think you have understood it. So you can copy it. Now this much is for today. So today also we did some problem. You revise all the problems that we did today, and you also do the homework that I gave you. And also you revise all the problems that we did so far in this chapter, integration of some special form of functions. And in the next online class, we'll do more problems on this chapter. Okay. So this much is for today.